I want to talk to you a little bit about some miscellaneous functions that are part of the standard library. There are many, many more, but these are the ones that you're going to run across most often. You will want to check out the library that comes with your compiler, with the documentation with it, or the man pages if you happen to have put in the CPP or GCC compiler under Linux. Here's some string handling functions. Stringcat, strcat, will concatenate the second string to the end of the first string. Concatenate. All of these S and T are string pointers through these samples, and N is an integer. Whenever we look at these string handling, these are all strings. These are single characters down here, the C's. Okay, just so you know. String ncat does a concatenation. Again, it concatenates T to the end of S, but only for this many characters, for N characters. So you have 3 parameters to a string ncat. That way you won't add any more characters than you want to, so that you don't overrun the end of S. Here's a string compare, S and T. If S is less than T, that's alphabetically. If S contains characters in it and the string is less than T in the alphabet, a negative value will be returned, because what happens is that T, character by character, is subtracted from S. So this pointer, this whole string, would be, let's say that this is S and this is T, concatenate and compare. This will be subtracted, this letter from this letter, and there's no difference. This letter from this letter, there's no difference. M from N, now there's a difference because M is less than, so we have a positive value. So concatenate comes after compare in the dictionary, so we would get a positive value saying that T is larger. Okay, so a negative will be returned if T is smaller. 0 is returned if there is no difference between the two. Like if we did concatenate and compare with only a 2-character N, string N compare down here, we only do 2 characters, then 0 would come back, because C would be subtracted from C and O from O, and there wouldn't be any difference in just those 2 characters. So that returns a 0 value. So string comp or string compare and string N compare return negative, 0, or plus, depending on which string is larger alphabetically than the other. Here's a string copy. We'll copy T into S, character at a time, until you get to the null. String N copy, there's a limit of how many bytes of T will be transferred to S, copied to S. Return the length of a string with string length. Here's a string character. We're going to look for this individual character in this string S, and we will return a pointer to this location within S, or if the character is not in S at all, we will return a null pointer of zeros. And here's string R character. We'll look for this character in the string S, but it will find the last one. It works its way all the way through the string looking for C, and remembers where the last one is and returns a pointer to it. So that's some of the basic string handling functions that you can use in C. Here's some character class testing and conversion. We've already used one of these, isLower, in our, toLower we used in our lower program earlier, where we converted to lowercase. But these are all tests, and they return 0 for false, or a positive value for true. True and false, just like we had before, non-0 and 0 for false. So we can test, these are all characters. We can test a single character to see if it is alphanumeric by calling isAlpha. We can look for uppercase, test to see if it's an uppercase character by isUpper, which will return true if it is and 0 if it is not. isLower, is it a digit, numeric digit? Is it alphanumeric? In other words, can we print it out? Is alnum? Is it a space for white space? That's things like a space, tab, carriage return, form feed, vertical tab, things like that. toUpper actually converts the character to uppercase if it is not uppercase already, and as we know, toLower converts to lowercase. When we want memory in a program, we are able to ask the operating system for blocks of memory. There are some basic memory allocation functions that are part of the library. Remember, these things are not part of the C programming language. They're part of the library. We can use malloc, which is a memory allocator, and we ask it for a number of bytes. So if we do an malloc and put 1024 in here, we will get back a pointer. It's called a void pointer because it doesn't point to any particular kind of thing. So it's a void pointer. We will get back a pointer to 1024 bytes of memory. That's what we asked for. The operating system will take that off the heap and give us a pointer to it, and it keeps track of the memory that's been allocated. A calloc or calloc does the same thing, but it will clear the memory out. It will reserve the memory using an malloc, and then it will set it to zeros. And we have two parameters to a calloc. How many of a thing that we want, and then what is the size. This is good for structures. You can say that you want X number of structs of a certain size, and it will figure out what size they are and then do the multiplication for you and get the memory set aside and then zero it out. So you have how many you want and how big each one is, and for calloc. Then, when you're done with the memory, as a good programmer, you have to free it up. So you pass the pointer into free, which you had received from malloc or calloc. And free tells the operating system via the implementation that you have it tells the operating system that it wants the OS to release this memory. It's no longer being used by our program. So that's a very simple memory allocation, and like I said, there's not a lot to it to ask for memory for structures or other things in the program. It's really quite simple.